could be cannonball, but it's just humans specifically.
Yeah,
It'll work the same.
specifically humans, yeah. Doesn't work for any other thing except gravity only works on humans when shot out of a cannon. So parametric equations, what it allows us to do is to look at the horizontal view of things, also the vertical view of things, right? They're independent of each other here. So parametric equations of the human cannonball. Let's do the theory behind it first here. So I got this little guy right here. So
could we turn the lights down?
yes,
Yeah.
thank you so much. I forget about that. Because I'm staring at a screen that is just perfect for me. And actually this right here. 1 second, I think I can do this, which should help.
Yeah.
Yay, better.
You need to record it.
And recording. Thank you so much. You guys are
First
keeping.
time it's ever happened all year. Usually reminded you.
Okay, let's go with it here. So first things first, the vertical plane. What happens here is sine theta. Hey, sine theta is the y-axis, right? Or the y values here. And looking at the magnitude of the initial velocity when you take off. And then you got this little 1/2 gt squared. How fun is that here? So gravity, still gravity taking its toll. So 32 feet per second. It goes up, then it comes down. So eventually we have this little thing that sets up here. So the x-axis is only looking at the cosine value. It's only the x values, bless you, coming across, multiplied by the, and if you want to write this one down, that's these two are the ones you probably want to write down here. So x is equal to, and it's the magnitude. So it's kind of like those absolute value markers.
So the V and then a 0?
V0, we call
So
it
this
V.
is the application problem.
So it's called V naught, K-N-O-T, or V initial, however you like to say it here, but it's just the starting value. And then it's cosine t, and then big O parentheses, and then you have this little cosine theta, and then you have this big O t value right over here. So it's a multiplier of this whole thing. For the sine function, or the y value, we get the same thing. It's the magnitude, initial velocity, sine theta times t, and it's minus 16t squared to accommodate for gravity. Bless you. Let's see, and I didn't get to your homework this weekend here, so we'll do this after the finish up 6.4 eventually. Hopefully today. I'm pretty sure today. Cool. Okay, let's shoot this guy through a cannonball. So let me jump to the problem itself here. So graph the path of a human cannonball's initial velocity out of the cannon 60 miles an hour. The angle is 30 degrees. And so depending on the angle, that's important because you have a trajectory on it. And then based upon how fast it's, or he or she is flying out of that cannon. So we've got to do this. We've got to figure out what in the world is V naught, first of all, or V initial.
Yeah, V not sounds like we're finding out what V is not.
Yeah.
And don't know why they even say it. Why would you? Because to me, whenever you say not, it's like knots, how fast a boat is traveling. That's sort of, so V initial, probably a better choice of words here. Okay, we're in, let's see, we're in miles per hour. The little problem is our formulas are in feet per second because we have those. And do you guys remember, you guys have taken chemistry before, is that right, maybe? Yes. Do you guys remember dimensional analysis?
Yes.
Oh, how many liked it? Raise your hand if you liked it.
Okay,
No,
well, once you got it, it
Yeah.
was really easy.
that's what I thought. Yeah, once you get it, like, oh, that's so
I
cool.
started mixing it up, and then it just never stuck after that.
Gotcha. Okay, so let's try this
Yeah, it
here.
never really became second nature. I always had to think
I had to
about
like
it.
think
And then
about
it
it.
got-
Like,
And it was on
no,
the
this way.
SAT.
And then it got so complicated.
Yeah, it got so complicated then.
I was looking at it, I was like, woo.
Let's see, we got miles per hour. We got to go all the way to feet per second. So I guess, let's see, feet per mile. We can cancel out the miles at this point right there. That's cool. Won't be as complicated. How about that? Not converting the moles. And back down.
Oh my gosh, it's like that different one.
Hours, let's get to seconds. So how about 1 hour, 60 minutes. Still not there. Let's convert minutes back into seconds still. So 1 hour, 60 seconds. I think I'm done. So let's see, make sure my dimensions cancel here. So 1 mile are gone. I'm in feet. Hours are gone. That's cool. Minutes are gone. Like it. Anybody with a calculator that can multiply all those guys together, then divide by the 60, and then divide by 60 again. And you need your calculator.
Can't you just do like 60 times 580 divided by 60 divided by 60? Like even if there are stuff in between, as
Yeah.
long as you do it in order, it's
Mhm.
fine.
Absolutely. Just make sure that you divide by 60 once and then divide by 60 again.
Got 88.
88, perfecto. Okay, we got 88 feet per second. Awesome. I got my two equations then. Let's see. So x is equal to 88. This is going to be cosine. And this is 30 degrees because it's the angle that it took off.
Why is it cosine?
First things
Because you're
first.
plugging it into this equation up here that we did before.
Yeah, And cosine, remember cosine is the x values, so it determines your horizontal plane. All right, all this in a big O parenthesis is multiplied by t. But 88 miles per hour, no, it's not 88. It's feet per second, that's different. Because Back to the Future, that was miles per hour, so a little different. Okay, y is 88 sine 30 degrees t. Okay.
Sorry, can you explain again what the 16t squared is?
Gravity,
Okay.
the pull on gravity back down.
It's funny that only y is affected by gravity. Like I get why, but it's just like, I just don't have to deal with it.
Let's see, x would have to eventually deal with air friction.
Hmm.
That's what it has. So the more complicated formula would be dealing with that.
So we're just gonna assume that it travels at the same velocity the whole time.
Mhm.
Like,
What if there's
traveling-
wind too?
Absolutely, just keep going.
Oh, no. It's traveling in space.
Where there's gravity for some reason.
If space had gravity.
Space along the x-axis and the y-axis is affected by gravity.
Yeah.
Gravity to the atmosphere.
How far up in the air are we? Are we like right in between space and like Earth's? Maybe it's.
Yeah, we built like a
gravity
platform,
pull.
so there's still gravity.
Too funny.
It's in a vacuum, just there's no gravity.
We somehow
The human is dead.
separated, yeah. Somehow in a 3D plane, isolated like 2D elements and just like,
Yeah,
they exist together, but we're keeping them separate.
Totally makes sense.
Yeah, exactly.
Okay.
If it lets us use this
Very
formula, I'm
useful.
like not mad at it.
very useful.
We're gonna have to graph this guy. So let's see, how about calculators probably?
Yeah.
Did anybody's calculator die at the SAT?
No.
No, I
I
had
just
one.
forgot
too.
mine at
Oh,
the
no.
SAT.
Wait,
or,
really?
Well, the PSAT.
Oh,
I was like,
I didn't take
wait,
the
you
SAT.
didn't go, but what?
Yeah, I didn't take the SAT. Thank
I
God.
did not replace the batteries and it did die, so.
I know, so
Yeah,
I didn't actually have replacement batteries.
I had backup batteries with me. I was like, if so, help me if I will.
Yeah, they
lose it.
say that the calculator section is doable without calculator. Some of the questions they were like,
Most,
okay,
I feel like
A
most
lot
of
of them
them, I
are,
don't
and then some of them, it's just like, no,
Uh-huh.
no way.
Someone for the non-calculator, I was like, I need to have it.
No, yeah,
Yeah,
that was.
non-calculator was so much fun.
Yeah.
Yeah, it's like some of them, they just waste
Yeah.
your time.
Yeah.
Yeah, exactly. And then they
Also-
only give you 20 minutes and
Uh-huh.
it's just like, I don't.
Did you guys get a fifth part?
Yeah,
What did
it's
you get?
because they test new questions.
What did you get for your?
It's not
It's like
put into your score.
yeah, it's not kinda against
It's
you.
just a.
Well, I got the section that I'm actually good at, so I was like,
Yeah,
Yeah.
I got a reading section. so
I got a
I'm fine
math
with that.
non-calculator.
Oh.
They
Yeah, I got
test
it right.
questions on you, that's so lame.
Yeah, but
Wait,
it's
why
not
did you have
counted
an
in your
extra
score.
Good.
part?
Time.
Because they test
Oh,
new
you did.
ones for the,
Yeah, it's only 20 minutes.
it was, yeah.
yeah, they test.
Okay, I got mine done like
Mine
2
is
years
so
ago.
behind.
You get paid to
because
test.
My proctor was the
Test
person
questions.
checking everyone in.
Yeah,
And so you would get to our class till like 8:20, so we didn't even like start the first section until 8:45.
So what did you do a
wow.
couple times?
So I didn't get out till 1.
Yeah, I got out before you, I had extra time on
Yeah,
mine.
we just like sat and. sat.
Wow.
It was.
Where was it at?
San and
Yeah.
Okay.
I got moved like 5 times.
All right, let's go with it here. So first things first is we've got parametric equations on our hands. And also we have degrees. So those two little settings there have to happen or else we're going to be really confused.
Right.
And
So talk to me as we go through it here. Make sure we go from screen to screen. We're good there? Cool. And let's go y equals, which should give us an x and y coordinates here. And so start off with parenthesis here. How about 88? I have cosine of, ooh, okay. Just kidding, 30 degrees. I close off the cosine parenthesis and close off the whole entire multiplier for the x value. And then let's multiply by t. Next one, same thing here, 88 sine, 30 degrees. Close off sine, close off the whole entire term. T minus 16. Let's go t squared. There it is. Okay. I'll let the fun begin here. Let's see. As we start graphing, think about, okay, person's taken off at 88 feet per second. I'm thinking, how long are they going to travel along the x-axis, then also the y-axis? Let's graph it. Let's see what happens here. So graph is here. Whoa, they took off. Zoom.
we zoom out.
And let's see, we can zoom out. Eventually we want to end up in
I
quadrant
guess
1 though, right?
The scale is not like what we would think it was, but it seems like gravity would affect it way more than that.
Yeah,
I,
it still looks like that.
no, zoom out.
Zoom out, okay?
Yeah.
Oh, there we go.
I put it
Yeah, it's a
on
little curvy.
And zoom out
minimum, x minimum 0 and max 250, and it gets the whole thing.
Oh, I see
Okay.
again. Wow,
it.
it goes into the ground.
Oh, wow.
He died.
He is dead. I have my
Yeah.
y minimum on 0, so I understand.
Mine isn't in that quadrant.
Nice.
Yeah.
I'm gonna go zoom.
Yeah, you might be in radians.
Wait, why
Oh, I
are
might
my
be-
minimum
yeah,
and
you're right.
maximum so weird?
Yes, I am.
Good,
So
okay.
smart,
That makes
dude.
sense.
So I got t value.
There we go.
I'm thinking it's t value affecting it. No, just window, huh? So 0. I'm gonna give a little cushion here. So x minimum is -10. Grant, you said 250?
Yeah.
Gets you all of it here. I'm gonna go by tens. And then this one, how high does it go? So I'm gonna go -10 as well
Not
here.
Very high, it goes like 30.
Okay, so I got 40 here. So if you want to set up mine the same way here. So I got X-min is -10 to 250. By tens, and then go -10 to 40.
There we go.
And then this one will go by fives, I guess. A little bit of a.
Woo, okay, that's a little better. Oh, according to my graph, he goes like into the earth.
Yeah,
Yep.
apparently.
Boom.
Yeah. Same.
Okay, what do we need to find? We need to find a few things here. All yours for, if I can get to the right slide. There it is. Okay, can you find the maximum height of the human? Let's see, maximum distance traveled horizontally. And the time at which the cannonball hits the net. Sorry, some of you guys are writing it down. Go for it. Writing it down. Then we'll try it on the calculator here. So max height, max distance horizontally, and the time it takes for the cannonball to hit the net.
Are we assuming that the net is the x-axis because it does just keep dropping?
Yeah, Assuming that where the cannonball fires and the net are in the same. Horizontal plane. Let's see, what's other assumptions here? Assumption is the net and the cannon are roughly ground level. Or else we'd have to count for that. Right? How high is it above the ground? And they actually are pretty high above the ground. Cannonball. Okay.
Find the maximum height by tracing it on the graph.
I
Or you have to
think-
solve for
I think we're gonna have to do it by graph. Getting there, okay. Let's go with it here. I gotta find that little point right there. And so let's see how the calculator does it as well here. So trace button, I think is helpful here. Trace. No, is it value? That's no fun. Oh, sorry, that's the calc button. We got to get the trace button. That's better, way better. Clicking this
it.
little
Yeah, it
button.
worked.
And then let's go. Guys fired out of the cannonball. Whee, and about right there, huh? So let's do this here. Let's zoom in on this little piece. Just want to show you something that the calculator does here. So notice it goes from here to here. Goes from this side to this side. As we zoom in, let's click on zoom, zoom in. And we're just gonna place a little dot right there, like somewhere right on the top, maybe like right in the middle right there. You guys can see that little blinking thing over there. It uses the trace button, the trace feature where you're at, and then it converts into this little plus sign. Okay, talk to me, just wanna make sure we're the same.
Mine was zoomed in, it looks like this, where it's actually like closer to it.
Uh-huh,
I don't know if
yeah,
that's-
yeah. Let's see if this one looks a little same about there.
Okay, yeah. So
Mhm.
was that what you were saying? Tina?
Uh-huh.
Okay.
So clicking on trace button again, up, starts off with 0, 0. So here goes da 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 da. Back to here, and notice, look, right on this top ridge. It's still, it doesn't, the calculator still uses the same exact coordinates it did before. It doesn't
Mine
when
was
you zoom
going
in.
a lot slower. It's like moving a lot slower. It's not as.
Oh,
jumping
interesting,
as
okay.
it is.
Grace has a special calculator, okay. So I'm thinking about there, that's close enough as far as a trace is concerned. So all yours, what's the highest height this guy reaches?
30.12.
Yeah, 31.2, maybe about there, 31.2.
I got 30.12.
30.2, thank you so much, yep. 30.2 is good by me.
Yeah. as soon as I zoomed in, the little cursor thing went off of the line and it's just like freestyling around.
Oh, Georgia, that happened.
Like I can just move it wherever I want.
Yeah, that happened to me. You have to hit trace again.
Yeah, same thing happened to me. It's like,
I was like, wait,
Now
this
it's
is.
not zoomed in.
nice.
Yeah.
Okay, everybody okay? I can come by, look at your calc if you need to here.
But the graph is
The
great.
important question of the day today is Adrian, is your calculator
No.
still dead?
Definitely not, yeah, oh yeah, the other, yeah, that's that.
Still dead?
Yeah.
Okay. You gotta resurrect that calculator sometime.
Oh, yeah, really, there's like 10 feet in between.
On the bright side, charging cable is supposed to be coming on Amazon, what's the one that actually comes.
That's cool.
It's kind of problematic,
Okay, let's go with
right?
let's go with horizontal distance traveled. Let's go with that.
Wait, so the height is 30.1 or whatever.
Uh-huh. So it's gonna do it by trace eventually. Notice, remember how we used to do the calc features on the function? There's a lot of them, right? For this one, it's just your, it's actually some calculus features on here. Okay, let's go, let's see, zoom out, I guess. Let's go back to what we did before here. So window, I'm gonna go again, negative 10 to 250. Negative 10 to 40.
Wait, what did you say? Sorry.
Sure. I went back to negative 10 to 250 for the X min and max.
Negative 10. X max is what?
250 goes by tens of the X scale, and the negative 10 to 40 by fives. So negative 10 to 40.
I can't even contact, I can barely see that.
Let's see, I can tell you,
Then
you just tell.
after- What's the Y minimum?
Y min negative 10.
Okay.
Cool. Y max is 40, and Y scale is 5. Cool. All right, I'm gonna graph again here. And now we need to figure out that little guy right there, that little trace value right there. So back to trace, and let's go with it. Whee! That right there, that's pretty close.
How do you make it go there? It's jumping back and forth.
Yeah, I just zoom in
Oh.
first.
Tell me, between what and what?
It's just like above and below the y-axis, it just keeps, it won't go right on it.
Oh,
Yeah, it
gotcha.
won't
Huh,
go
it's going
clo-
jumping
as
from here to
close
here, right?
as- Yeah, it's not going as close as yours.
Okay, let's do this here. Let's zoom in on it.
Yeah, mine jumps over now.
Uh-huh.
Mine is at 0.04.
Oh, nope, yep, that was a mistake. I don't know what I just did.
Mine's on. Oh, why is my graph moving all the time?
Mine's also 0.04.
Oh, I think I got it. Wait.
Oh, now it's a lot
Put
close.
what we wanted the y value to be, and it would take us to the x value of that.
Uh-huh.
Table. Wasn't that table?
Huh, yeah, my y will go from either negative 0.12 and then I go up and it goes 0.6.
Gotcha.
So I can't get to
In that,
0.
in that case, what you do is you just see, look at the closest one to that. It shouldn't change too much here. Let's see. X value.
Maybe I need to zoom in again.
Yeah, notice my little cursor jumps from here all the way down. And so it doesn't start going slower either.
Yeah, but yours is at negative.
Yeah, mine's pretty close there, yeah.
How do you get yours so close?
I
Is it
do
just
not know.
calculator?
Just the way, yeah, it's just a calculator. Uh-huh, just the way it's moving. Let me just check out something just
Wait,
real
so it's
quickly here.
209.5.
About there, yeah, uh-huh. Let me just check. Do table set. No, that won't do it here. That would be
209.
209.5. I got 208.5, but his more.
wonder if we'll do. Okay. T1. Let's see. It's the T value. Gotcha. Okay. Okay, just to get a little closer, if we wanted to, go back up to the graph here, and then let's hit trace. And notice this little value, the T value is at 2.7. What do you guys have? What's the closest you guys get to?
When I hit trace, it has y at 0, but everything else is at 0. And I didn't do
So-
that much.
That's fine. You just start off with the initial condition. So now, Grace, go to the right arrows until you get to over here.
Get either 199.5.
What's your
Or
T value,
290.
Amaya?
Let me check. Wait, that's in my. How do you set up your,
It should just be right here. As you're in trace mode, it should give you a T value, then X value, then Y value.
wait,
When I
2.61.
2.61. Okay, leave that in just a second here.
when
2.61.
I'm hitting trace, it's bringing up these things up top, which is giving me the coordinates that we typed into y, but now it's not letting me trace anywhere. It's not moving.
Cool. Okay. Let me do that, and then we'll go to table. That'll be a little bit easier. So see.
Cool, that's what I have.
Nice.
Interesting.
Just like, wait a minute.
Yeah, I was just looking for it, just like, well, I guess.
Oh yeah, here's.
Guess they just said no.
Uh-huh.
I was the Morgan, so how this, I was gonna have to. You guys been doing anything?
Oh,
So let's get it.
No.
Correct, 2.61.
Yeah, so that's why I was thinking.
I went to bed at 11:50.
Gotcha. Okay, let's keep that 2.61 in your mind.
Last night.
That's when I fell asleep. That's not when I was in bed, but that's when I fell asleep. Like,
Okay,
Gosh, I like gone.
12:30.
Georgia, the next thing here, I'm not sure if you have it or not, but there should be a table set, some kind of table set button in there.
I'm not seeing the word table anywhere.
like,
Okay. I will have to look at seeing your video here.
and I was
Okay,
driving home
let's
and I was like-
look with me, and then
I
I'll
am
hopefully
so
send you
fucking-
something that is go good. So, Amaya and Grace, you guys have both had 2.6 something, right?
Yeah.
I'm looking at 2.7. So let's start off at 2.70. But let's do this here. See this little table set button right here above window here? Let's go second function table set. And let's start off at 2.68, maybe something like that. Or 2. Actually, no, let's go 2. That still would be too close here. 2. Six. Yeah, let's go 2.61 where you left off. And this one's going to be 0.01. It asks for independent, dependent, but if you have an X1 and a Y1, that will be your two values here. And then you have the table itself, and it's on top of the graph. Notice this guy in yellow here, it's on top of the graph function. So click on second and then click graph. And you should see something that looks like this. And so the X value is your horizontal distance across, your Y value is your height. Are we good? So as we go down, and notice the height is coming down, so that's what, 3 feet above the ground?
I can't go down.
Just down arrows.
Yeah, I can't.
Great.
Your calculator doing something funny. Okay, let me see, click the enter. And enter again. Okay, now so you can click on. Okay, click on.
Oh, is it because I'm zoomed in and so it only shows me the points on my?
No, see, you're changing. These guys are changing way too fast. here, So go back to table set. Okay, starting off as that. Oh, auto. That one. Okay, now
Now.
table. There it is. Now. we're
Aha, thank you.
Okay, yeah. Hayden.
Sure.
Okay, you guys find me the,
I was trying to figure out how to.
The zero.
The zero.
I got 2.75.
Maybe I rediscovered how much I hate car batteries.
Oh,
What?
oh no, that's Y zero.
Yeah,
Wait,
is that why
we
you're
need
late?
one
Yeah,
zero,
no,
right?
yeah, I got two
Yeah, no,
low
you're good.
nine.
Wait, wait, no, yeah, I need to do our X
It
value.
would take like an hour or whatever. Okay, I was gonna say.
What? We want the X
That's
value.
also the reason why I didn't have a second.
Oh, wait, so, yes, 209 is the X value.
Yeah.
Sorry, I was looking at sheet.
I also discovered how much I hate traffic portable
I
charging.
literally just.
Yeah, no, I hate car batteries as well. They don't give me
Yeah, I
can
any
feel- yeah,
everyday
And like when I
conditions.
go like
Right,
that,
truck,
that's
just-
so.
You turn the key
Literally,
in
why
the
don't
ignition and it
sunscreen
says
not-
low
sunscreen
battery,
filters.
then it doesn't
Well,
start.
my leg.
And then the second.
My
time it
fans
starts,
are
it
like
does this
that.
consistently,
I
every
feel
time I
like
freak
I
out.
almost-
It's like letting you know that one of
And
these times it might not start the
And I
next.
felt so
Exactly.
good to lay
I
on
see
the
it
side.
getting better.
And I was like, I'm gonna get hurt, I'm gonna put my clothes
Well,
on, and I
that's
realized
true,
I already
yeah.
brought a tank top. I'm like, well, this is not helping at all.
Yeah, my knowledge is being.
I'm like, well, at this point, I might as well just got burned all over.
I can't believe this is
I was very impressed with the speed.
How do you change it so it has more key, like, because mine is just, why am I not saying words right? It's just,
And I was like,
Window.
no. And I was like, oh, I thought you asked this. And I was like, wait, no, I thought you asked this. And I was like, wait, did you ask this? So the answer is yes. I mean, the answer is no. And he's like, and I was like, I'm sorry, what did you ask? And like 5 minutes ago, what did you say?
I did that where my mom was talking to me and I realized I wasn't listening to anything she was saying. I was just saying yes. And she was like, I asked you how you were feeling.
At like 4 in the morning, I was just nodding, and I was like, I'm gonna know what we're talking about anymore. I'm just like,
Yes.
Yes.
Okay, let's go for it here. So let's go to until it hits 0. And let's see, so we're at 2.71, 2.72, 2.73. Yes, love it. Look at that. It actually hit the 0 exactly.
Wait,
Did
so
you
the
guys hit
T
the
is
zero?
time?
T is,
What is
T is time in terms of seconds.
Oh.
So it took
so we need to
2.75
convert it?
seconds.
So if you think, so T is like if you took the line and just like stretched it out flat and measured it, that's what T is? Like the length of the line and then
After
stretch it out.
2.75 seconds, he hits the ground.
Yeah, T is from Y is at 0 to Y is at 0.
Right, but I'm just wondering how you'd measure that practically, just like on the graph, what that would symbolize.
It's not measured on the graph because these guys are independent things here. So on the graph, what's happening is it's the,
1, 2.
it's the T values as they go, right? So T is equal to 1, there's a certain dot out in the X and Y plane. Does that make sense?
Yes.
Okay, so
the
T is not
can't
measured.
be represented on the graph. It can only be like solved
Yeah,
for.
is he just like phasing? through the
Correct,
ground?
It's on the graph, but it's which point is graphed at that point.
He clearly included that.
Okay, you guys talk to me here. Are we good?
Wait, so
Yeah.
then the time at which he hits, or the cannonball hits the net is 2 point.
2.75 is what we got by the table.
Travel past children on the block.
2.75 seconds.
Exactly. It's like a speeding bullet into the ground.
Yeah, and it takes only
And will
2.75
somehow not
seconds to do
crush the
that,
one
and
in
you're just
that.
like,
And it's just now traveling towards the Earth's core,
or human channel.
probably generating a plasma trail from the speed that it's moving. Yeah.
Okay, we good there? Let's see. When I click on table,
It's just a drill now.
where I'm at, where this little highlight is at, if you go back to table set, you find out that's exactly where it is right now. Can you dig in more into the table? Absolutely. If you want to go like this, 0.001, you can go in and as precise as you like with the table. Because notice right here, if I click on table now, this way, if I click on table now, guess what? It's going to take me a long time to get to 2.75 now, because I'm doing every 100th place. I'll be here. Not too bad. Look at that. We're at 2.72. We got 2.73.
2.75, which is what we got.
And kapow.
Log. Do the values keep going past that? Or is it the end?
No, they keep on going, which
Nice.
would not.
Do you see like bouncing?
No, that's still going below the.
Yeah, he's
Oh,
going.
He's
right.
burrowing at this
Yeah,
point.
I forgot he was
Burrowing.
spacing through the ground.
Okay. One more thing to show you guys here. Let's see. Let's see, 2.75. Okay. How about this? If you go to window, the reason why he goes into the ground is because our t values keep on going, right? And so if I go t values from 0 to 2 seconds.
Oh.
And it doesn't know that we're
Oh, so
thinking
if
of
you
it
put-
in a practical sense, like
Yeah,
we have a real
T-max at
analogy.
Wait,
instead of
why is it
just-
doing
Correct, yeah, you're
Yeah.
starting the t value, you're stopping the t value.
Yeah.
It makes a incomplete little.
So you put it at 2.75.
Oh,
He's
he's just hanging there.
Wait, so you can see where he is after in enough time?
He is suspended.
He's just.
Oh!
Okay.
Inertia has just stopped existing. And he's just there. He's just suspended
Just
in
in a-
there, yeah.
Thing of like really big tree sap, like
Inertia and gravity. Yeah.
consumed him, and now he's frozen in amber, and they're gonna like find his fossil in a million years, just in the middle of the air. It's gonna be great.
Okay.
Yeah, in a million years.
Ah, oh my gosh. Wait,
You gotta love those.
I.
A different species is gonna make human park. Amber flash flood freeze. Exactly.
They'll bring back humans.
Mine,
Jurassic
how
Park.
do you figure out this side? 'Cause I
Should have a negative value for your x.
Didn't you realize that you're a million?
Because I can't see mine.
Oh, yeah. Like, come on, guys.
Wow, that's a lot.
Yeah, it's very, I hate when it happens to me.
See how it's already at a positive value? If you switch it to like negative
In fact, that's why I was like, the school just did it.
10.
Was it? Yeah. I was on my way and I was caught in an amber flash flood. Good job not making something a million years.
That's a different excuse from my
Yeah,
dad being my home.
Yeah.
I left it in Cretaceous, so I should have gotten here in time, but the amber.
Okay, are we good? Does that make sense? Let's jump to, of course, got to do a video of a guy doing some crazy stuff.
Oh.
Finally makes sense like that, that's so animalistic. Yeah.
Is it on fire?
It's on fire. And the ring of fire.
Wait, he's not going inside. Yeah. This looks so weird. This looks terrifying. Oh, he's very far on the net.
Yeah.
Oh, nasty.
Anyways, that was cool.
In that case, is the cannon exactly lined up with the net, because we're treating that like the ground?
Uh-huh.
Okay.
And let's see, as it goes up, actually the net is a little bit, looks like a little higher.
So basically they just
So
calculated.
now
Yeah, they just landed it on the ground. I don't think
We'll catch them somewhere.
And that's
The
just
net was
sitting
just on the ground. Like, don't worry.
Yeah.
They might have just shot like 4 or 5 cadavers out of a cannon to figure out where they need.
Yeah, I was thinking about that. I was like, they're not gonna test him.
Yeah.
See, where you land is gonna be
Depends on
where
how much they pay.
I am for sure they calculated it. Like Evel Knievel, when he did his stunts, he had 3 physicists that he actually worked with in order to make sure it actually is going to go. So notice sometimes that he'll start and he always has a little escape lane. And so that's exactly it, because he has to hit a certain miles per hour and hit the jump just right, and he always had a little escape lane. Yeah, in case he's just not there, the miles per hour. Anyways, we're good. Okay, 6.4 is done.
Okay.
I will send you guys homework for 6.3-ish. Come with homework questions for 6.4 on Wednesday. We'll kind of finish up that chapter. Okay? And have a good day. I figure we'll take it slow today. We're good?
Yeah.
Oh, man.